right, so it says solve the equation 0 equals 2x to the second power plus 4x minus 16 graphically. So using a graphing calculator, we're going to graph each one of the equations. So I want you to put your x-intercepts right where it crosses the x-axis. So go ahead and put your x-intercepts on the two places where it crosses the x-axis. So then we'll count over and we'll identify what those x-intercepts are. Now, the reason why we find our x-intercepts is because the other day we said the x-intercepts are also called solutions. So if we're looking to solve the equation, we're trying to find the solutions. So we're going to make a little note by the first example 1 graph. To solve means find the solution. And the solution means find the x-intercepts. So at all the graphs today, we're going to graph them in Desmos, and you're going to identify the x-intercepts. So the x-intercepts appear to only occur in 2 whole number units. So the x-intercepts are -4 and +2. Go ahead and circle those. So we have the point -4, 0 and 2, 0. Those are our 2 solutions because those are the x-intercepts. So the solutions to the equation are -4 and 2. And for each time we identify the solution, we can check that that's a solution by using substitution. So everywhere that there's an x in the original equation, so we're going to write down the original equation. So this was our original equation. It was 2x to the second power plus 4x minus 16. So we substitute the -4. That's what they did here. So they noticed that they got 0 as the y value when they plugged in -4. And then you substitute in +2. So wherever the x is, you're going to substitute that number into the equation, and then we use the calculator to verify that it's equal to 0. If it's equal to 0, then we put a check. That means the solution is correct. So we have a way to be able to check our solutions today. All right, now we're going to go to the second example on that first half of the page. So this one says solve 0 equals 3x squared minus 6x minus 9. So we're going to circle that. That's what it's asking us to solve graphically. Use the graphing calculator and sketch the graph of f of x equals 3x to the second power minus 6x minus 9. So I'm going to open up a Desmos graphing calculator. And we're going to type in the equation. F of x equals 3x to the second power minus 6x minus 9. So the x-intercepts, the good thing about Desmos is if you click the points, it shows us what the x-intercepts are. So we have -1, 0, and 3, 0. So the x-intercepts appear to be -1 and +3. So we're going to put our first x-intercept right here on -1 and our second one right here at 3. And then we draw our parabola like that. So the solutions are the x-intercepts. So the solutions are -1 and +3. So now we're going to go back to our original equation. Everywhere there's an x in our equation, we're going to substitute the 2 solutions that we just got. So I'm going to rewrite all of this, and I'm going to leave the little set of parentheses blank. So the first time that we do this, we're going to check the first solution. So everywhere there's a box, we're going to substitute -1 because that's our first solution. So then we can type this into the calculator. We have to do 3 times negative 1 to the second power. So I come over here and I type in 3 times negative 1 to the second power. That gives me 3. So I'll put 3 in this first blank. Then I have to do negative 6 times negative 1. And if you have to type this in the calculator, that's fine, which is equal to positive 6. So we're going to make that a positive 6. And then we're going to minus 9. So now we're going to put all that together. 3 plus 6 minus 9, that's equal to 0. So we want these to equal 0 so that when we check it, we know that we got the 0 or the solution. This time we're going to plug in the other solution. This time we're going to plug in 3. So everywhere there's an x in my original equation, I'm going to put in 3. And now I'm going to type this into the calculator. 3 times 3 to the second power is equal to 27. And then I have negative 6 times 3, which is negative 18. And then I'm going to put all that together. 27 minus 18 minus 9. Which gives me 0, and that's what I wanted. I want everything to cancel out to just be 0 because I'm looking for the x-intercepts, or the zeros of the equation. So that's number 2. So Braden drops a rock from a bridge into the water below a height of 144 feet. So go ahead and underline that, 144 feet. The function d of t equals 16t squared models the distance from the rock to the bridge after t seconds. Use the graph to determine how long it takes for the rock to hit the water. So to write this equation, we take the first part, the 16t to the second power, and we set that equal to the height. So this is the equation that we could write. And we want to solve this, but first we want it to equal 0. So to move this 144 to the other side of the equation, we have to do the opposite, which is to subtract it. So what we do to one side, we have to do on both sides. So the new equation that I'm going to type into Desmos is 16t squared minus 144 equals 0. So when it equals to 0, we can solve it by finding our x-intercepts. So lucky for us, it already graphed it for us. We just need to put our points on our x-intercepts. So that looks to be 3 and negative 3. I know it's kind of weird to see. It's counting by like every 2 blocks is 3 or 1. So the x-intercepts are 3 and negative 3, but if we're talking about time, we're talking about seconds. We can't have negative time, so we can't have the negative 3. It has to be the positive 3, since we're talking about seconds. We can't have negative solutions for our real-world examples. So we're going to verify that positive 3 is the solution. So everywhere that there is an x or a t in my equation, we're going to replace that number with our solution. So we put our solution of 3 in, and it gives us a height of 144 that we started with. So 16 times 3 to the second power is 16 times 9. 16 times 9 is 144. And if you can't do that in your head, you can put it in the calculator to check it. So the rock will hit the water in 3 seconds. That's our final solution. So Fritz is crossing a pedestrian bridge over a canyon that is 784 feet deep. So you're going to want to underline that. He drops a stone into the canyon from the bridge. The function, it's the same one, d of t equals t to the second power. So we're going to use a graph to determine how long it takes for the stone to reach the canyon's floor. So we're going to determine the values of t. So we're going to set this equal to our distance, 784. So we have 16t to the second power equals 784. Use a graphing calculator to solve. Well, we got to set it equal to 0, so we have to do the opposite, which is subtract 784. So we're going to solve 16t squared minus 784 equals 0. So we always take the height, and it's going to be the opposite, which is subtraction. So choose a viewing window that shows both x-intercepts. So I'm going to come over here. I'm going to erase all this. We've got 16, and instead of t, I'm just going to type x into Desmos because Desmos likes x better than t, minus 784, and then I click on the x-intercepts. So I get two answers. I get 7 and negative 7. 7 and negative 7. So the solutions to the equation are 7 and negative 7, but only use the positive solution to determine the time. So that means that it's going to take 7 seconds. So t equals 7 is our solution. And we can go ahead and draw this on our graph as well. We just plot our two x-intercepts. We know our solution. Now, everywhere that there's a t in my equation, I'm going to substitute the number 7, and we're going to confirm that we get the original height of 784. So I need to do 16 times 7 squared. So 7 to the second power is equal to 49. So I'm going to do 16 times 49. 16 times 49. Oh, I pressed the wrong button. There we go. 16 times 49 is 784, and that's good because that was the height that we started at. So we need to check our solution for the real world example to make sure that we get the same height as we started with. So the stone will reach the canyon's floor after 7 seconds. So once you write the equation, we just solve it by graphing by finding the x-intercepts.